So I love this video, and I wanted to start with this video. This video is absolutely amazing. If you can see these 4 little pixels of light dancing around, those are actually 4 planets in another solar system, not our own. These are 4 planets circling around a star that's been blacked out in the center so that you're not blinded by it. And these 4 points of light are about 129 light years away, very far away. And this is actually an actual movie of actual planets going around a star that was taken over 7 years. And it's, I don't know, it's just amazing to me. And I really love the fact that we've discovered a bunch of exoplanets or extrasolar planets or planets that are around other stars. And the way we've been discovering most of them, though, hasn't been through actually seeing them, but through detecting them. We typically detect them using the transit method. And the transit method is something where a telescope will look at a starlight like this very, very closely, and it will see if it can see a tiny little dip in brightness. And if it sees a tiny little dip in brightness, it might actually be witnessing an exoplanet passing in front of its star. So you can see it here in this animation. And so most of these exoplanets have been discovered through a space telescope, one of my favorite, called KEPLER. And KEPLER uses this transit method to be able to discover and explore other planets in our universe without actually seeing them. And I think the fact that it was named after Kepler, Johannes Kepler, an astronomer, is actually very apt. Because Johannes Kepler was an astronomer in the 1600s, and he wrote in the early 1600s Somnium, or Dream, which was one of the very first works of science fiction. And in Somnium, he imagined, in the early 1600s, about how humans could travel to the moon, and how they could do a bunch of really cool science there, and how they could look at the Earth from the moon and do a bunch of cool science about the Earth from the moon. It was really incredible, this work of science fiction. I think he sort of dressed it up as fiction because it was the early 1600s. And this was also the time of Galileo, who famously was persecuted for a lot of his astronomical observations and for saying that maybe not everything revolves around the Earth, that perhaps the Earth revolves around the sun. And so Kepler wrote what I think was probably something that he thought was science-based, but dressed it up in fiction as a way of avoiding persecution. What's really incredible to me is the fact that this was written 361 years before the very first moon landing. So 361 years from the time of Johannes Kepler's writing to the time of actually landing a human on the moon. Enter the 1960s, where we were sending humans into space, and we were about to send a person to the moon and land on the moon in 1969. And suddenly this dream that became, I don't know, it took 361 years in the making, and suddenly this dream became very exponential. People thought, okay, we're now sending humans into space and to the moon, and so we're going to send the very first spaceship to Venus. And maybe going to the moon isn't exotic enough. We have to send men inside the moon. And we have to go even farther. We have to journey to the far side of the sun. Or we have to journey to the 7th planet, which is Uranus. I can't imagine why they didn't include that in the title. But then even that wasn't far enough. We had to voyage to the end of the universe. And this was actually a film that is said to be one of the influences for 2001, A Space Odyssey. And this film had a lot of minimalistic qualities. And in 2001, A Space Odyssey, which now we're in its 50th anniversary, it became sort of a cultural touchstone to some. It was very minimalistic, it was very primary colors, it became something that sort of, over time, for a lot of people, represented this is what space exploration is supposed to be, and this is what space exploration, when we're actually going out and exploring further and further, will look like. And this is something that you see echoes of even to today, 50 years later. You see films like Interstellar, which also have a very minimalist aesthetic and sort of have this idea of what space looks like, that there's not a lot of stuff, that it's very, minimal colors and very limited in terms of aesthetics. And then this bleeds over into real life. On the left, you can see a spacesuit design by SpaceX, and it's very minimalistic, sleek lines. And on the right, you can see a mock-up of a spacesuit from Boeing for NASA, also tapping into sort of the primary colors from 2001. And I think what's really interesting about this is I think a lot of times what we're seeing today are people imagining that they need to make space exploration exciting, and that there was this golden era where more people were excited about space exploration and more people were into it, and we need to harken back to that time and place and tap back into the excitement. And so they go back into these design aesthetics from 50 years ago. But the reality is that when you look at the data over decades, it doesn't support this idea of a golden era of space exploration. This is a chart that shows the number of people in the US who are very interested in space exploration over time, from the 1970s to the 2010s. And it's something where it's interesting to look at because, it goes up and down a little bit, but it more or less is around the same. And there's not some big cliff that everyone started falling off and started saying, oh, I'm not interested in space exploration anymore. It's been about the same, kind of, for lack of a better term, lukewarm. Another chart from the 1970s to the 2010s shows people in the US who thought that the moon landing was worth it. So actually, in the 1970s, coming off the heels of the moon landings, you can see that less than 50% of Americans thought the moon landing was worth it. But over time, more people think it's worth it. And so this is an interesting concept that a lot of times when you look at some of the public polling data for space exploration, people who are actually living through it might not think something's worth it or might not imagine it as greatly, but fast forward to a few decades, they look back at it with nostalgia and perhaps have a more favorable view of it. And so these charts were curated by a committee on the future of human spaceflight from the National Academy of Sciences. I was part of this committee, and it was a pretty unusual experience for me. It was something where Congress requested that the National Academy of Sciences do a report on the future of human spaceflight, how to make a sustainable human spaceflight program over several decades, and also, why do we do this in the first place? Is there a reason? And so this was something that was really unique, actually. The National Academy of Sciences was originally set up, directed by Abraham Lincoln, as an independent organization to comment and criticize and make recommendations and advise the nation, the US, on science. So having an actually independent organization look into the science that the US is doing and have an independent voice on it. And so, unlike most committees that get very specific experts in very specific domains, this one was a little bit different. The Human Spaceflight Committee was compiled of people who were economists, people who were former Secretary of Defense, planetary astronomers, astronauts, also particle physicists, historians, and there was me. So it was a really incredible 2-year experience, and I learned a lot about both the history of space exploration and the future of space exploration. And so when thinking about the future of space exploration, I often like to look at the past as well. So in 1969, we had a fairly historic event. We sent a human to the moon. But also in 1969, a historic but lesser-known event took place. We sent the first message over ARPANET, the early form of the internet, and that message was LO for login, and the computer crashed shortly thereafter. But about 50 years on, only around 550 people have ever been in space. Now nearly 3.5 billion people, about half the planet, more or less, is on the internet. And so to me, this is incredibly sad and broken and something that needs to change. But I also know that going into space doesn't mean all of space exploration. There are so many people who work on space exploration around the world, and you don't have to go into space to do space stuff. But Again, 50 years later, I still have problems with a lot of the imagery that we're fed and a lot of the stuff that goes viral. So in 1969, you can see this is an image from the moon landing, and in 2018, this is an image from the SpaceX Falcon Heavy launch. So this is frustrating to me because not only what it depicts, but it doesn't reveal the whole story of what exists today and right now. Yes, space exploration needs to be more diverse and inclusive, for sure. But also, I know that there are amazing people who work at SpaceX and who work at NASA and who work all over the world in space exploration that aren't represented in these images today. And that's frustrating to me. And so, halfway between those two images, approximately, in 1990, this image here was taken. I would ask how many of you have actually seen this image before, but I can't see you. So I'm going to imagine a lot of you because you're pretty geeky. But this is one of my absolute favorite images from one of my favorite spacecrafts, Voyager 1. And if you can see that tiny little pale blue speck of a pixel there, that's Earth as seen from about 4 billion miles away. So that's where you can find me if you need me. But the reason why I love images like these so much is because it often shows how space exploration changes our view of ourselves and our place in the universe. But most of my work, as you can imagine, is about changing how we view space exploration. And it's really space observation for most people. That's really the relationship that most of us have with space exploration. We're often watching government agencies or astronauts or Elon Musk explore on behalf of us, but we ourselves aren't doing much exploring. And this relates to my own personal story, because a few years ago, I was watching a documentary called When We Left Earth. And it was this great documentary about NASA during the early days and how they were trying to figure out how to send a human to space for the very first time. And I was watching this, and I became so incredibly inspired by it that I decided on a whim to send someone at NASA I had never met an email saying that I was a huge fan of what they were doing, and if they ever needed someone like me, someone completely without a science background, I was here. I went to art school. My degree is in graphic design. I don't have any background in science or space whatsoever. So I sent this email thinking that I would never hear back from it, but it was just a fun thing to tell friends, hey, I emailed someone at NASA. But serendipitously, I heard back from that email. And not only did I hear back from that email, I ended up getting a job at NASA from that email. And so it completely changed my life, and it was incredibly inspiring. And so I wanted to share with all of you a quick clip from this documentary that better explains just what I found so inspiring about it.
To beat the Soviets, NASA must launch a man into Earth orbit. Only rockets can go fast enough.
We knew nothing about rocketry, we knew nothing about spacecraft, we knew nothing about orbits.
I saw a lot of rockets launched. I'd say that somewhere between 30 and 40% of them failed. A lot of them came up off the pad and went the opposite direction. Some of them got halfway off the pad and blew up. Some of them got to 10,000 feet and turned the other way and blew up.
The whole thing crumbled and blew up. It looked like an atomic bomb went off almost over our heads.
We got a big kick out of watching the Mercury astronauts. It was great looking at their eyes.
We're looking at this thing and looking at each other and deciding we want to go back and talk to the engineers a little more before we go further.
And so that's what I totally love about that documentary. It actually always reminds me of this image here. That NASA in the early days didn't know everything. They were still figuring things out. And you heard them talking about how they didn't know anything about rockets or orbitry or spacecrafts. And I was sitting at home and saying to myself, well, I don't know anything about space exploration, and I want a job at NASA. That sounds amazing. And so I got that chance to work at NASA, and it very much changed my relationship and my perspective of NASA from being a bunch of rocket scientists to being a bunch of space hackers. That these were people who were still figuring things out as they went along, and they weren't necessarily experts before they did things. And my relationship with space exploration changed, and this is really around the idea that doing something changes how you see it. So actually doing science and doing space exploration actively changes your relationship with it from something of observation to something of participation and contribution. And so while I was at NASA, I got to learn a great deal of things. It was like getting paid to go to school. I got to learn about dark matter and robots and all this amazing stuff. But one of the important things that I ended up learning while I was at NASA was that I don't need to be an astronaut in order to explore space. And not only did I end up learning that I don't need to be an astronaut to explore space, but I ended up learning that I don't even need to work at NASA to explore space. And so I left. And I created SpaceHack.org, which is a directory of ways for anyone to participate in space exploration with or without a formal science background. I built SpaceHack.org 10 years ago this year, and I really wanted it to be a way in which people can accomplish a bunch of amazing stuff, and that it actually values people from different backgrounds and different disciplines and different geographies to contribute to space exploration. And so SpaceHack.org wasn't exactly built to teach you how to build a bottle rocket in your own backyard. I'm sure that's a lot of fun, but it wasn't about that. I built SpaceHack.org more for kids who might be saying, well, I don't have access to rockets and I don't have any money, but I want to test stuff in space, so I'm just going to send my frickin' teddy bear in space. And this is exactly what 11 to 13-year-old kids did in the UK, is they wanted to test how different materials react in space, and so they sent their teddy bears up on a weather balloon into near space to test how they reacted, at least in that environment. And this is just the sort of stuff that I love. But one of the problems that I had when I built SpaceHack.org 10 years ago was that NASA a lot of times scrubbed the faces out of human spaceflight and out of space exploration. And I think I know why they did this. They did this because, if no one's really being represented in space, then maybe everyone can imagine themselves being there. And that's not necessarily bad, but to me it made space exploration about as bland as the food that they send up into space. You didn't really get any ideas of people's cultures or personalities, or not very much. It was pretty limited. And so you lost out on a bunch of stories that are only now really coming into focus. So I'm sure a lot of you have seen the movie Hidden Figures about Katherine Johnson and many of the other human computers and mathematicians that ended up contributing to the NASA program in the 1960s. And there are other stories out there, like the fact that NASA really struggled at one point with the Saturn V rocket, putting on this specific type of honeycomb insulation onto the rocket. They couldn't really get it to adhere to it. But they learned that there were some surfboarders down the road who worked with this material regularly. And so they ended up temporarily hiring surfers to actually work on the Saturn V rocket and apply all of this honeycomb insulation onto it. These sorts of stories really got washed out over the many years, and it was very frustrating to me, and I really wanted to give light to a lot of the stories that exist in space exploration today and that will be existing in space exploration tomorrow. But 10 years on, there's a new problem. The pendulum has really swung the other direction. And now, instead of having no one really being represented in space exploration, we are kind of in a system where only one person's face is represented in space exploration. And this is equally problematic to me. It's something that I think creates the same problem, just on the other end of the spectrum. We miss out on all the thousands and thousands of stories of people who contribute to things like this and who contribute to all sorts of space exploration around the world by having kind of cults of personality, so to speak. And so you may hear a lot of these titans of commercial space talk about why we even go. Why do we even go to Mars? Why do we even send humans into space? Why do we do space exploration at all? And if you listen to Elon Musk or Jeff Bezos or many others in this area, they will tell you that we are doing it for human survival, that a single planet species will not survive, that the only way we can survive as humanity over the long run is to become a multi-planet species. It's not that that's necessarily wrong or incorrect, but it's misrepresentative. As part of the National Academy of Sciences Committee, we looked into public polling and surveys, and we talked to stakeholders, and we listened to many testimonies about why do we even go to space? Why do we do this? And the reality is that there are many reasons why we go to space. There are pragmatic rationales like science, economic benefits, international relations like soft power, inspiration of citizens, national security, and then there are aspirational rationales like human survival, and also shared human destiny and aspiration to explore. These are essentially a lot of the rationales that we heard from many different people, from many different places, and these are kind of the distilled down categories that we found out through our research. And so when someone tells you that the reason why we're doing this is because we need to survive as a multi-planet species, they're kind of lying to you, because that's not representative of all people. That's not why everyone agrees that we do this. In fact, most people will oftentimes cite multiple rationales for why we go into space. And so it's not that I have any problem with people picking and choosing which different rationales we have for going into space, but the problem I have is that if you act as if that is the rationale, that you are representing everyone, you're kind of lying to everyone. You're trying to control a narrative, and the narrative is really multifaceted. The narrative is really the fact that a lot of people have different reasons for why we do this, and they don't agree, and that's okay. And a lot of times, it's the combination of the pragmatic rationales with the aspirational rationales that have a really robust argument for doing this. To me, I want to shatter this single narrative and sort of break this script that I feel like that we've gotten onto from science fiction and from commercial space titans and from many people who are loud voices in the room. It's not necessarily that I'm trying to say that they are wrong, but they are trying to control a narrative, and I feel like, in a way, space exploration has become scripted. So I want us to go off script. And to me, this is around the idea of creating massively multiplayer science, something that really represents people from all different disciplines and backgrounds and geographies and everything coming together at the same level and making awesome science and stuff. And so I get this from, of course, massively multiplayer online games. And it's something that when you look at them and you see, how people defeat a big monster or how they accomplish different tasks, a lot of times it's because people need to come together and have different skill sets to be able to accomplish something. So if you try and build a team of all people with the same skill sets to defeat a monster, you're probably going to fail. And if you try and build a team that maybe you've only got a couple, you might also fail. But if you build teams where people are coming together and they have different skills and it's respected at the same level, where people are coming together at the same level, then you can accomplish a lot. And so to me, I want to live in a present day that looks more, wackadoodle like this. I want to live in a day where space exploration is representative of all of the diversity that it has and all the diversity that it can have. I want to see amazing spacesuits that look like this. And these are actually spacesuits that are developed by a project called the Spacesuit Art Project, which was started by astronaut Nicole Stott. And they are wackadoodle not only in their appearance, but they're great in the fact that they actually are a patchwork of people coming together and making these happen. This project reached out to a lot of children in hospitals in different countries around the world. On the left, you can see children from Houston, and on the right, children from Pakistan, working on building different parts of these spacesuits. There's also amazing stuff like 3D printed sculptures that have already been sent out into deep space. But the thing that's cool about this 3D printed sculpture that's been sent out into deep space, and by the way, I think it's the only one that's ever been sent out there. There's not a ton of them out there. It's not like an art garden out there. But so these space probes, or this space probe is 3D printed, but it's this 3D printed sculpture that was a collaboration between engineers at Tokyo University and art school students at Tama Art University, as well as some hackerspace people coming together and making a 3D printed sculpture that they sent out into deep space. But to me, the really cool thing about this is that this space probe had a bunch of sensors on it. And so as this space probe went into deep space and actually experienced what it was like in space, it generated poetry based on its experiences and sent it back to Earth. And I just love things like this. Another project that I've come across over the years that I adore is a group of researchers who wanted to 3D scan supernovas. So supernovas are the explosions of massive stars when they die, and they create these incredibly beautiful images. And so they wanted to look into, well, what if we could 3D scan supernovas? Well, you can't exactly take a 3D scanner and point it up towards a supernova and get a 3D scan of it that way. And you can't exactly shrink a supernova down and run it through an MRI machine and get a 3D scan of it that way. But in a sense, that's what these researchers ended up doing. They used an open source piece of software called 3D Slicer that usually creates 3D fly-throughs of brain imagery. And they thought about, well, what if instead of sending it brain imagery, what if we gave it supernova imagery? And so they fed it Cassiopeia A, this supernova remnant here. And the result they got was this. This is the very first 3D fly-through of a supernova that's ever been created. And in a way, I guess it's an MRI of a supernova. And this was created through a project out of Harvard called the Astronomical Medicine Project. And as you can imagine, it was a collaboration between the astronomy department and the medicine department to see what they could do and what sort of visualization techniques they could share and what sorts of software they could share to create new and better solutions on either side. And they ended up creating a lot of really clever solutions. So you would think these sorts of collaborations take place all the time. I'm from San Francisco. This is an actual map of how far away Google is from NASA Ames. Not very far. They're right next door to each other. So you would think there would be all this amazing collaboration taking place and people just socializing with each other. NASA people would know Google people and vice versa. No. A few years ago, I had some friends from NASA who were taking a tour of Google. And they were walking around Google and looking around and going like, oh my God, we are at Google. This is so cool. Equally, at that time, I saw people from Google saying, oh my God, there's people from NASA here. This is so cool. And I thought that was delightful, but it also incredibly frustrated me because it shouldn't be like that. They admire each other. They look up to each other. They should already be collaborating and socializing with each other. And it frustrated me that they weren't. So sort of born out of this frustration came an event called Science Hack Day. And Science Hack Day is a weekend event that gets scientists, designers, developers, and people from all different disciplines together in the same physical space to see what they can rapidly prototype with science in 24 consecutive hours. So the mission of Science Hack Day is just to get excited and make things with science. For me, the secret mission of Science Hack Day was to give all of these people an excuse to be in the same room together and finally start collaborating like they should. And so Science Hack Day takes place all around the world. I've had the great pleasure of visiting a lot of the communities around the world who do Science Hack Day. I had a great chance to go to Madagascar, where they were creating IoT chicken coops and different devices that would deter locusts, which is a big local problem with the crops. And they just were amazingly fun and silly. I also went to Colombia, where a lot of people were looking into combining plants with electronics and looking at different ways to design parks so that they would better accommodate people with disabilities. I also went to China, where people were looking at building necklaces that respond to the weather, or they were looking at different ways in which they could paint with biomaterials, which was fun. And so Science Hack Day is now in 29 countries around the world. It's something I'm incredibly proud of because no one owns Science Hack Day. Science Hack Day is a grassroots thing. You don't need permission to organize one. There are open instructions on sciencehackday.org on how you can do a Science Hack Day in your own city. And it's just a lot of fun, and it just keeps growing, and it's amazing to see what people are producing all around the world. And so I wanted to share a couple of examples from Science Hack Day that better explain the things that I love about it. So this is a hack that someone created at Science Hack Day in which someone wanted to create a typeface in which all the letters had equal wind drag. So what you're looking at here is a makeshift wind tunnel, and someone actually cut out the individual letters of the alphabet and then recorded the wind drag of each individual letter, and then weighted each individual letter so that all the letters would have equal wind drag. So if you need a typeface in which all the letters have equal wind drag, it looks something like this. I have no idea how this is useful, but this was created by a physicist named David Harris, who was playing around with typography. And this is something that I love about Science Hack Day, and when I talk about massively multiplayer science, that yes, people are coming and learning new cool stuff about science, but equally, scientists are learning new ways of prototyping with design and tech, and everyone's learning from each other equally. So David Harris actually went on to, after Science Hack Day, get a master's in arts, and I think is even getting like a PhD in art school. Like, he's going all the way for this. So it's just amazing to see people go across both sides. Another fun hack from Science Hack Day is Satellite Symphony, in which you can go to this website, you can type in your location anywhere around the world, and it will tell you what satellites are currently overhead. But it will, in addition to telling you what satellites are currently overhead, it'll put them to music based on how far away they are or how fast they are moving. So this is something that I think is a lot of fun because, you know, when you're at school or work or home, you can sometimes hear the traffic outside, and you get an idea of how congested or not it is outside, and you get an idea of like when it's quiet. And increasingly, with more and more people launching satellites into low Earth orbit, we don't really have a sense of how busy is it, how quiet is it, does it get busier during certain times? And so in a way, Satellite Symphony sort of creates an ambient awareness for that. Another all-time favorite hack that I've loved is someone who wanted to create a device that would detect when he needed to shave. And so, you know, he wrote some basic code and used an open computer vision library, and you can see the computer vision trying to draw lines around the stubble on his face and tell him when he needs to shave. But this actually was something where a particle physicist thought this was actually a really great way for detecting cosmic rays in a cloud chamber. Which sounds ridiculous until you see what cosmic rays in a cloud chamber looks like. And so actually, following Science Hack Day, this particle physicist ended up creating a multi-year student-led research program around detecting cosmic rays in a cloud chamber that was based on the original code and open computer vision library someone had used to detect whether or not they needed to shave. And so this is what I love about hacking and prototyping in general. It's really about creating sparks for future ideas and future cool stuff and future collaborations. And I wanted to touch on some of the experiences from Science Hack Day, but specifically quote my friend Lindsay, who's a designer, on her experience with Science Hack Day. She says, "Science Hack Day introduced to me for the first time people who worked for NASA. It was a small revelation, even as an adult, these heroes of my childhood were just normal people, not magicians, unicorns, or untouchables. They were people who loved geeking out on space as much as I did. Science Hack Day introduced me to a community of scientific professionals who treated me, a non-scientist, as an equal." And so I wanted to share some of these multidisciplinary things that have come out of just people working together and working with different technologies. This one is something that I actually really love to show to Eyeo because it's something where you're watching a video of how the sun goes across the moon each day. And someone wrote some basic computer vision to try and route a rover on the moon to stay in continuous sunlight. So typically rovers on the moon would have to power down overnight because of their solar power, and they can't do science during that time. So someone was like, well, what if we have more efficient rovers that never go to sleep, that always do science, and can stay in continuous sunlight? So they use computer vision just to create more efficient routes for rovers on the moon. This is a project that got funded by NASA, and it's amazing to me because this is something that uses very present-day tech, but when applied towards space exploration is actually quite futuristic because stuff like this has not been used before. And so really we need people from all different disciplines contributing to space and other things in science, and things that seem not very sci-fi futuristic to us might be sci-fi futuristic to another discipline. And so this was funded by a program at NASA called NASA Innovative Advanced Concepts, or NIAC. And NIAC is the kind of only program at NASA that funds the more futuristic sci-fi out there sort of ideas and concepts that could be transformative to future space missions 10, 20, 30, 40 years down the line. Things where maybe it's not possible to achieve them today, but you can still do credible research into it. And so if this is something that's interesting to you, the thing that's really cool about NIAC is that anyone can apply. You can be a garage hacker, you can be an academic, you can work in NASA, it doesn't matter, you can apply. And so if you go to niacfellows.org, they're actually going to open up their solicitation in August. I think they close it again in September. But in August, you can apply, and all that's needed is a 3-page white paper to apply, so it's not a big ordeal. And it's something that's really just cool and fun, and I think we need a lot more people from different disciplines and different backgrounds applying to this. And so other projects I've come across that I really enjoy have been, one was a competition to detect the effects of dark matter. So dark matter, we can't actually see dark matter, but we can detect the effects of it. Dark matter is something that when we look at galaxies and we see that they're held together, we can't actually see enough mass to account for enough gravity to explain why they're held together. And so we give this invisible mass the name of dark matter. But dark matter isn't uniform. Dark matter is globular. It globs on around galaxies. And so while you can't see it, you can detect the effects of it. And so there was a competition to create better algorithms for detecting the effects of dark matter. And the reason why I love dark matter so much is because it reminds me that we are in a very friendly universe, that there's this invisible stuff that's holding us all together and keeping us all close so we don't drift away from each other. One of the algorithms that came out of this competition came from a glaciologist who used algorithms that he was already using to detect the edges of glaciers in satellite imagery. And he applied that towards detecting the effects of dark matter, and it ended up beating out all the other existing algorithms at the time. And I just love stuff like that. Other stuff I love are copper-pooping microbes. So a synthetic biologist by the name of Lynn Rothschild applied to this NIAC program, and her project was all around creating synthetic microbes that can eat lots of different types of metal and stuff that's in electronics, and then poop out copper. So what these little microbes can do is they can take dead or spent electronics, and they can chew them up and then poop out copper to create new circuits and new electronics. And this is something that's really useful on Earth, but also super useful in space, because you can't bring that much stuff with you, and you need to recycle pretty much everything you bring with you. And I like this because, to me, when you think about how to solve a problem like this, a lot of people might go to people who are electronics experts, but this is an idea that came from synthetic biology. There are other projects that I love. This one was also by the same synthetic biologist, Lynn Rothschild, along with a lot of others. And what they did is they went around the Earth, and around the surfaces of the Earth, they collected microbes, and they collected the size and shape of microbes, but also the color of microbes. So they went to oyster ponds and deserts and all different places that were on the surface of the Earth, and they created this palette. And they created this palette because one day soon, we're going to get even better images of exoplanets than the ones I showed you at the very start. We're going to hopefully soon start getting images of exoplanets that actually have color in them. And so what this actually ends up becoming is sort of like an alien Pantone guide. You could actually, as we get images of exoplanets, you could hold this up to the planets and be like, well, I think maybe this different microbe could be causing this color, and maybe it's a way of actually detecting alien life. And I love this because this is something that designers can do and artists can do. There are so many different ways of detecting life because we haven't done it yet, that we really need people thinking creatively about how we can do it. And it's something that I think is needed a lot more because whether we're detecting intelligent life or not intelligent life, it's something that is a big up-and-coming thing. I can't tell you when, but it's really exciting to create things like alien Pantone guides that might help future people detect aliens. So Life detection is something that I'm increasingly getting really interested in and involved in. Later this summer, in August, I'm going to be going aboard the exploration vessel Nautilus, the EV Nautilus, which is a 64-meter research vessel, and we're actually going to be going and exploring an underwater volcano off the coast of Hawaii. And we're going to be doing this because there might be extreme forms of life living around this underwater volcano that are very similar to how life could exist perhaps on Enceladus, a moon of Saturn that has an icy shell but an ocean underneath it, and it has hydrothermal activity. So we're looking at underwater volcanoes here on Earth so that we can better understand how life might exist elsewhere in the solar system. And this is something that's really exciting because they 24/7 live stream the expedition. So from now, right now, you can probably load it up until, I think, November or so. You can go to nautiluslive.org and see what they're exploring in real time, which is really exciting. So if you tune in like late August to September, you might hear me. Another fun project that I've got coming up later this year that I'm incredibly excited about is that I am going to Antarctica. And I'm going to Antarctica to better understand and look at the weird forms of life that exist beneath the ice there. Something that I do in my spare time is I catch tardigrades in my own backyard, also known as water bears. They're incredibly cute. This is one I got in my own backyard and did a microscope video of. What I totally love about Eyeo, by the way, is that I am the second person to have a video of a tardigrade. I think that's just amazing. I'm in the right place. So yeah, that will be a fun project. But I often get asked, though, well, what about life as we don't know it? So we're studying all this life here on Earth so that we can better understand how it might exist in space, but we don't know that it'll be anything like life here on Earth. What about life as we don't know it? And this is something that's important for weird places in our solar system, like Titan, another moon of Saturn, that has lakes of methane and ethane and electrically charged sand and all this weird stuff. But it doesn't have liquid water, so pretty much anything there isn't going to be using oxygen. And so a team of astronomers partnered with some chemical engineers to imagine what life could possibly be like on Titan. And so what they came up with was this. This is a cell membrane that they designed based off of nitrogen that could survive in liquid methane and ethane, but not utilize liquid water. But to me, I think, if we're at the point where we're already designing life as we don't know it, we should be designing exploration as we don't know it. Exploration that goes off the script, exploration that is multidisciplinary, exploration that is representative of all the amazing people who are contributing to it, but all the amazing people who could be contributing to it immediately, and inviting them in. And so to me, science fiction and very loud voices oftentimes illuminate a path for us. So sometimes science fiction will illuminate paths that we should go explore, like Johannes Kepler did, or very loud voices in space will say why we do this or where we should go. And it's okay that they illuminate paths, but I don't think they should also then be allowed to be used as gatekeepers to who can explore, how they can explore, why they should explore. They shouldn't be gatekeepers unless, of course, they are Stargate, in which case, well, I guess they wrote that into that. But, to me, it's really about creating a patchwork, something that is representative of all the exploration that's going on, and where we actually get to hear all of the stories. We don't get to hear just one or none of them. We get to hear all of them, and we get to give them a lot of equal weight. And so, to me, this might mean that exploration becomes more nebulous or more undefinable or difficult to pin down because not everyone's going to agree and because there's going to be so many voices. But I think that's really important. And I think this is something that John Peel sort of got into with this quote here.
I mean, I think at the heart of anything that's good, there should be something, there should be a kernel of something that's indefinable. And I think if you can define it, or claim to be able to define it, then in a sense you've missed the point.
Thank you.